Dear student, good morning. Today we'll discuss the problem based on conversions. As you know that question based on conversion is an essential format for the question asked in CBSE examination, and this has been always a problem for the student to solve the conversion. So today I am giving you some important tips to solve conversion. The first and most important thing is, if you want to solve conversion easily, you will need a thorough understanding in the chapter studied. Means the chapter studied, what are the chapters you have studied till now? Haloalkanes. Then in class 11th, you have studied alkane, alkene, and alkynes. Second, just now you have studied haloalkanes. Remember, haloalkanes gives all possible functional group. You know that haloalkanes can be converted into alcohol, haloalkanes can be converted into carboxylic acid, haloalkanes can be converted into amide. So haloalkanes give all possible functional group. And the third thing is, you have studied alkanes in class 11th. So this is related with alkane. The most common reaction if your starting material is alkane is free radical substitution, that I will discuss in due courses of time. You know, the most common conversions in organic chemistry includes when the reactant is converted into product, either increase in the number of carbon in the product or decrease in the number of carbon in the product. So I am giving you some important tips when this question comes. Then if you are dealing with the aliphatic conversion, when there is an increase in the number of carbon, it's called ascent of series. And when there is a decrease in the number of carbon in the product as compared to reactant, it is called descent of series. Ascent of series. This reaction involves the increase in the length of carbon chain, that is ascent of series. It can be achieved by Wurtz reaction, which you have studied in class 11, through acetylides. You have studied this reaction in alkynes in class 11th, through cyanide. In class 12th, you have studied in haloalkanes, and through Grignard reagent. You have studied in class 11th as well as in class 12th in haloalkanes. So these are the reactions which deals with the ascent of series. It means it increases the number of carbon in the product when the reactant is converted into product. So first we'll discuss by Wurtz reaction. This involves the conversion of lower hydrocarbon to higher hydrocarbon. You know, suppose your starting point is alkane. So when I said earlier, when alkane is the starting point, then what is the most common reaction? The most common reaction is free radical substitution. So here, this depicts free radical substitution. So alkane is converted into chlorine in the presence of UV light. Alkane is converted into alkyl halide, and this alkyl halide is the starting material for Wurtz reaction. So in the presence of Na and ether, two molecules of alkyl halide is converted into higher alkanes. NaCl is removed and RR is connected, so you will get higher alkanes. So suppose your starting material is methane, so you will get methyl chloride. So as I said, two molecules participate. So number of carbon in the product side would be 2. So you will get ethane. So methyl chloride is converted into ethane. So here you see there is one carbon in the reactant, but in product there are 2 carbons. Similarly, free radical substitution in aromatic compound takes place in the side chain. Remember, free radical substitution is a main reaction of alkanes. Okay, so suppose the example of aromatic hydrocarbon is given. Remember, no change takes place in the ring It always takes place in the side. This is the side chain. Okay. So when this toluene is treated with chlorine in the presence of UV light, so you see one hydrogen from the side chain is removed and you will get benzyl chloride. And this benzyl chloride, when take part in the Woods reaction, then you will get 1,2-diphenylethane. I repeat, 1,2-diphenylethane. So this is the reaction when examples are given based on the aromatic hydrocarbon. Remember, in aromatic hydrocarbon, the substitution takes place in the side chain. Then this is alicyclic compound, cyclohexane. So their reactions are same as aliphatic compound. When it is treated with halogen in the presence of UV light, one hydrogen from the cyclohexane is removed by halogen. So you will get chlorocyclohexane. And this chlorocyclohexane, if it is the initial material for Woods reaction, so it will form dicyclohexyl. So this is how there is an increase in the number of carbon in different species. Okay. Then second example of ascent of series is through acetylide. Through acetylide. You know, in class 11th, you have studied acidic nature of alkynes, where you have seen that being acidic in nature, it reacts with base to form acetylide. So acetylide is basically the base of alkynes. When alkyl halide is treated with acetylide, this is acetylide, sodium acetylide. So NaCl is removed, NaX is removed, and you will get R is connected with the alkyne, and you will get higher alkynes. Okay, so this is lower alkynes is converted into higher alkynes. So this is the example given. You can add alkyl group on both the sides. For example, this is alkyl halide, your reactant. Then this is disodium acetylide. So alkyl halide can be added on both the carbon. So you see, this is the higher alkynes you will get. Okay. One example is given, methyl chloride to propane. Suppose this is your question, how will you convert methyl chloride to propane? So methyl chloride to propane, it means one carbon is converted into 3 carbon, and that product is unsaturated. So definitely it will be through acetylide, sodium acetylide. So this is methyl chloride and this is sodium acetylide. So you can increase the, depending upon the situation, you can take the example of sodium acetylide. Okay, so this is methyl chloride and this is sodium acetylide. So it will give propane. Then third and very important example of ascent of series is through cyanide. You know, cyanide is, just now you have studied in nucleophilic substitution reaction how alkyl halide is converted into cyanide. So when alkyl halide is treated with alcoholic KCl, it forms alkyl cyanide. This alkyl cyanide contains one carbon more than the alkyl halide. This cyanide can be directly converted into, this is a very important part, this alkyl cyanide can be directly converted into carboxylic acid, acidamide, and primary amines. When cyanide undergoes complete hydrolysis in the presence of dilute acid, you will get carboxylic acid. When cyanide undergoes partial hydrolysis in the presence of concentrated acid, you will get amide. When cyanide undergoes reduction either in the presence of lithium aluminum hydride or sodium or alcohol, then you will get amides. So these are the important compounds which you obtain from cyanide. So you see, alkyl halide can be converted into carboxylic acid, amide, and amides. Then after ascent of series, there are few examples of descent of series. It means the product contains less number of carbon than the reactants. The first example of descent of series is by soda lime decarboxylation. This you have studied in class 11th in methane, in alkane, sorry. So sodium carboxylate undergo treatment with the soda lime, which is a mixture of NaOH and CO. Okay, it undergoes the process of decarboxylation and alkanes are obtained. So you see alkane contains one carbon less than the reactant. Okay, so this is through soda lime decarboxylation. One more example of descent of series is very important, which you have not studied in first chapter, that is through Hoffman's bromide degradation reaction. This you will study in due courses of time. So amide in the presence of bromine and KOH is converted into amide. So starting material for Hoffman bromamide degradation reaction is amide, which is converted into amide. You see there are two carbon, the one carbon is out, so you will get the product which contains less number of carbon. Okay. Apart from the tips mentioned here, now there are some other important tips which you have to keep in your mind while solving the conversion. The first one, Sarchef rule and Markovnikov rule must be kept in mind while dealing with the alkenes and alkynes. Second, free radical substitution of alkane, electrophilic substitution of benzene. If suppose aromatic conversions are asked, then you know that free radical substitution like halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and acylation, etc. And third, addition reactions of alkene and alkynes, ozonolysis of alkene and alkynes, which you have studied in class 11. So these are the things which you have to keep in your mind when you are dealing with conversions. Now this is the example which is given in NCERT, example 10.9. How the following conversion can be carried out. The first question is propene to propane 1-ol. Now when you're solving the question based on conversion, the first thing is you write down the formula of both reactant and product. So I have written the formula of propene and propane 1-ol. This is the product. So this is propene and this is propane 1-ol. Okay, then only the things will be clear in your mind that how will you convert propene to propane 1-ol. So you have studied addition reaction in class 11 when propene is an unsymmetrical alkene, and remember you have to keep when you are dealing with unsymmetrical alkenes, then you have to keep Markovnikov, anti-Markovnikov in your mind. So it is propane 1-ol. Definitely the halogen should be added at the first carbon. It means the anti-Markovnikov rule is followed. An anti-Markovnikov rule takes place in the presence of organic peroxide. So I have mentioned here propene plus HBr organic peroxide means the anti-mark addition takes place. So you will get 1 bromo, and remember anti-mark is for bromine, not for chlorine and iodine. So you will get 1 bromo propane, and this 1 bromo propane, once the alkyl halide is formed, this alkyl halide, you know that halogen is a good leaving group. So halogen can be replaced by OH easily when it is treated with aqueous KOH. This you have studied in nucleophilic substitution reaction. So this is how propane 1-ol is obtained. And suppose if question comes propene to propane 2-ol, then you have to convert propene to propane 2-ol through Markovnikov rule. Okay. Then the second question is ethanol to but1-ine. So this is ethanol to but1-ine. So ethanol has 2 carbon, but but1-ine has 4 carbon. So this is an example of ascending of series. And but1-ine, it means alkyne. So definitely the conversion should be through acetanilide, So example of ascent of series. So you know the best way of converting alcohol to alkyl halide is when it is treated with SOCl2. So alcohol is converted into alkyl halide through SOCl2, CH3CH2Cl. Then it is treated with sodium acetylide to give but1-ine. Okay. Then the third question is 1 bromopropane to 2 bromopropane. So this is 1 bromopropane and this one is 2 bromopropane. So there is a change in the position of bromine atom. So definitely it should be through mark addition because propane is unsymmetrical alkane. So first of all, You have studied dehydrohalogenation in class 12th. So alkyl halide, and when it is treated with alcoholic KOH, it undergo dehydrohalogenation. You will get propene, and then propene when treated with HBr addition reaction, Markovnikov addition, then you will get 2-bromopropane. So this is how 1-bromo is converted into 2-bromopropane. Then the next fourth question is toluene to benzyl alcohol. This is toluene and this one is benzyl alcohol. And you see the ring is not affected in the conversion, but the side chain is affected. And there is one way to, to deal with the side chain is free radical substitution. So first toluene is converted into benzyl chloride, and then benzyl chloride when treated with aqueous KOH, this Cl is replaced by OH. Remember you studied in haloalkanes, aromatic hydrocarbon is reluctant to give nucleophilic substitution reaction. So here, therefore, side chain substitution, free radical substitution plays a very important role in replacing hydrogen by chlorine first and then by OH. Then fifth one is benzene to 4-bromo-nitrobenzene. 4-bromo-nitrobenzene. Actually, the nomenclature is wrong. It should be benzene to 4-nitrobromobenzene. Okay, because you know that this bromine and nitro, they are the substituent. So only one rule is applicable for substituent. Their name and their preference is given in the alphabetic order. So numbering will be done from here: 1, 2, 3, and 4. So it is 4-nitrobromobenzene. So benzene to 4-nitrobromobenzene. This is a question based on directive influence. You know that NO2 is metadirecting, whereas halogen is ortho and para-directing. So this is a question which is based on to which group is introduced first. It is bromo or nitro. If nitro is introduced, then meta product is formed. If bromo is introduced, then ortho and para product is formed. So therefore, you have to first introduce bromo. So how bromo is introduced? Through halogenation, and this is halogenation reaction. So bromo is introduced, and then this bromobenzene undergoes nitration, and then you will get major para-nitrobromobenzene or 4-nitrobromobenzene. 1-bromo 4-nitrobenzene. This is the example. Then the next conversion is benzyl alcohol to. The next conversion is benzyl alcohol to 2-phenyl ethanoic acid. So as I said, first you have to write both the reactant and product. So this is benzyl alcohol to 2-phenyl ethanoic acid. Okay. So it is once again it is an example of ascent of series, but ascent of series is needed in the side chain, not in the ring. Okay. So once again the same thing. First alcohol is converted into halide. And you know that side chain gives the same reaction as alkanes. Okay, so this OH is replaced by Cl when it is treated with SOCl2. Then Cl is converted into Cn. This is Cn, and then Cn can be converted into acid directly by complete hydrolysis. The next one is ethyl alcohol to propane nitrile. Once again, this is an example of ascent of series. So I hope you can understand it easily. This is converted in alcohol is converted into halide, and halide is converted into cyanide. So these two examples are same. Next one is aniline to chlorobenzene through Sandmeier's reaction. This is a very easy conversion. So first aniline is converted into benzene diazonium chloride, which undergoes Sandmeier's reaction to give chlorobenzene. The ninth one is 2-chloropropane to 3,4-dimethylhexane. Once again, this is an example of ascent of series. So 2-chloropropane and 2-chlorobutanes undergo Woods reaction. You will get this product. Then the next example is 2-methyl propene to 2-chloro 2-methyl propane. This is an example of mark addition. Halogen is added to the carbon which contains less number of hydrogen. So halogen is added here to this carbon. So this is I have taken some examples. Now there are how many questions are there? There are total 20 questions are there. So 10 I have solved. Rest 10 it's your duty to solve. And I hope that the rest 10 which I have not solved, you will be able to solve with the help of these tips keeping you in your mind. That's all for today. We'll